This is part 4 of our polynomials unit. We are going to be looking at adding and subtracting basic polynomial expressions. Before this, we looked at algebra tiles and how to represent polynomial expressions. We'll be using algebra tiles quite a bit in this video, so I want to make sure that you feel comfortable with that before you move on to video number 4. So, here's an expression, a polynomial expression, 2x squared plus x plus 1. I'm going to represent it with algebra tiles below. So our x squareds are represented with this big square, x by x, that's why. We have 2 of them. Our x is going to be represented with a rectangle here, and our 1 value is going to be represented with one small square. Here's another polynomial expression. We're going to represent this with algebra tiles as well. So we have 3x squareds, we have 2 x's, and we have 3 1's. I'm going to add together these 2 polynomial expressions. So let's take a look when we add them together. I'm going to take our first expression, throw it over there, and I'm going to do the same thing with our second expression. And then I'm simply going to count how many x squareds we have, how many x's we have, and how many 1's. So here's my x squareds, 1, 2, 3, 4, 5. How many x's do I have? 1, 2, 3. And how many 1's do I have? 1, 2, 3, 4. And there we have it. So 2x squared plus 3x squared is going to give us 5x squareds. 1x and 2x is going to give us 3x's. And 1 and 3 is going to give us 4. So there's our representation with algebra tiles. And here's a representation with an expression for our answer. So representing this with negative values, we just simply color code. I use red to represent negatives in this video here. So we have negative 2x squared, so this is going to be negative large squares, so red, plus 2x, there's our 2 rectangles, minus 4. So we have 4 1's here. We're going to represent this expression as well with algebra tiles, so 3x squared minus 4x plus 4. Boom. 3x squared minus 4x and plus 4 1's. I'm going to ask you to add these 2 expressions together. Now, it gets interesting here. We are in a debt when we have red. We owe an x squared and we owe 4 1's. So what we can do with our debt is we can fill it. So if I have 4 1's here and I owe 4 1's, how many 1's do I have in total? And that is when we can start knocking things off. So I'm going to get my pen out. Let's use black. And then I can start cutting off what is owed. I can do that here as well. I have 2 x's, but I owe 4 x's. So when I pay back what I owe, how much do I owe still? I still owe 2 x's. We can do that with our x squareds. So any red and blue pairs knock each other out. So what do I have left? I want to see I made a mistake here. I only had to knock out 2 of my blue squares. There we go. So we have 1 blue square left and 2 red x's left. So that's going to give us an answer of x squared minus 2x. And it makes sense. If I have minus 2x squared plus 3x squared, how many x's do I have left? X squareds. I have 1. 2x plus negative 4x, well, that's going to be negative 2x. Minus 4 plus 4, that's become 0. So there's actually a plus 0 right here that we're just not showing. All right, distributing the negative. So I'm going to take this polynomial expression here. I'm going to distribute a negative sign through it. So I want you to recognize that this is separate from what the example I'm showing here. I'm not actually going to subtract the next expression. So here's my polynomial with algebra tiles. And then we're going to multiply a negative just to see what happens. All right, I'm going to teach you something called the distributive rule. And you probably should know about it already, but we're going to review it for the polynomial unit. So we're going to distribute that negative. So when I distribute, it's going to go to each term that is inside the bracket of that negative sign here, because I am taking away everything inside of this. So if I'm taking away everything here, I'm taking away 2x squared, I'm taking away 2x, I'm taking away 3. So we're going to distribute that negative to show the language. There we are. Taking away 2x squared, taking away 2x, and taking away 3. To represent that with algebra tiles, we're going to flip the colors. So here I have a positive set of algebra tiles, but if I decide to subtract that expression, it's going to flip everything to become negative. So we're going to continue with another example. So here's another expression represented with algebra tiles. And I'm going to pretend to subtract that expression and see what happens. So now we're going to take away this expression. Okay, so remember this is separate. We do not want, this is just our original example here. And we are just looking at what happens if I have a negative, if I'm taking away the expression. So this time I have not all blue tiles, but I have some red ones here. So we're going to distribute our negative sign. When we distribute our negative sign, we can also flip our algebra tiles. So the negative sign is going to disappear, our blues are going to become red, and our reds are going to become blue. Which makes sense. When I distribute my negative, right, when it goes to all three terms here, the negative times the negative is going to become a positive. Okay. After you distribute, you can add and collect your terms easily. So from our previous examples where we just added together those polynomials, we can now do that after we distribute the negative. We have 4x squared plus 2x plus 4. I want to represent that with algebra tiles. So we have 4x squareds, 2 x's, and 4 1's. Here we have x squared plus 2x minus 2. I'm going to show you with algebra tiles below as well. So x squared plus 2x minus 2. We're going to subtract this expression from our first. So we're taking away x squared plus 2x minus 2 from 4x squared plus 2x plus 4. So I have the negative sign down here between our algebra tiles as well. Now from our last slide, we learned that we can distribute the negative through, and we can also flip the colors of our polynomials down here with our algebra tiles. And then the negative sign can disappear, and we can add them simply like we did before. So step 1, distribute. So here's us distributing. So our negative sign is just going to become a positive here. It's going to be adding now because we're expressing it differently. Here we're taking away this whole expression, and now we're just taking away each term in that expression individually. So same outcome. Now we got to show that with our algebra tiles. So we're going to do the color switch. Okay, let's show that one more time. Excellent. So we have x squared, negative x squared, so it's red, negative 2x, so it's red, and now it's a positive 2, right? So I'm taking away negative 2. Now if I take away negative money from you, are you happy or are you sad? Well, you're going to be happy that I take away your negative money, or if I take away what you owe. So that's why it's like you're gaining money. It's positive 2 here. So now we can simply add our polynomial expressions together. Remember, because this is a positive here, we can just add, and because we have a red and a blue, we can get rid of those colors. So you can knock out the red and the blue, knock out these two x's, and that's it. Now we can count what's left. So we're going to add together everything here. So we have 1, 2, 3 x's, x squareds. We have 0 x's left. And we have how many ones? 1, 2, 3, 4, 5, 6. And there's our 6 there. So now without algebra tiles, I'm going to show you some examples with questions here. If you have algebra tiles on you, or you're just going to be writing down, you can represent them by drawing squares like this. For x squared, you can have for x, and just a little square for 1 here. So that's what you can use. These are going to be simple expressions, and that I mean that with whole numbers that are small. So here we have 2x plus 4x squared minus 4 plus 5 minus 3x. I want you to notice that this is not in standard form. Neither expression is in standard form. I did that on purpose to confuse some students on their first go. I want them to recognize that the 4x squared is on its own in this case. You'd have to add the two x's together and the 1's together. So what we're going to do is something called gathering like terms. So below I've gathered my like terms. I put my x squareds together, I put my x's together, and I put my 1's together. And I simply just add together my like terms afterwards. So I color coded them for you. And there's our answer, right? 2x minus 3x is going to give you negative x. Negative 4 plus 5 is going to give you a 1. Let's try this problem here. So feel free to pause the video and try it on your own. All right, I'm going to color code and gather our like terms. So some people have highlighters that they use. You can like kind of underline your expressions if you wanted to, right? Some people can like go, here's my x squareds, here's my x's, and here is my 1's. Some people can do that. So I'm color coding. I have negative 2x squared plus x squared. How many x squares do I have? I have 5x minus 3x. How many x's do I have? I have 6 minus 3. How many 1's do I have? Now you probably caught on to it. There is a distribution law happening in here. I don't have to distribute, but it really helps. So I distributed. So that's why our negative x squared is now a positive x squared. That's why our positive 3x is now a negative 3x. That's why our positive 3 is now a negative 3. So once we add all those together, we get negative x squared plus 2x plus 3. Now let's say you didn't distribute. That is okay. There's lots of ways to do this. You can do it like so. All right, so negative 2x squared, right here, negative 2x squared, taking away negative x squared. Now remember, if I take away a negative, it's like I'm adding. So negative 2x squared minus negative x squared, it's going to give you negative x squared. Then I have 6 minus 3. So 6 taking away 3, that's going to give us 3. Then I have 5x taking away 3x, that's going to give us 2x. So you can just talk yourself through the answer if you wanted to. Here we have 8 minus 2m squared plus 5m, taking away the expression of 3m squared plus 2 plus 2m. So you can pause the video, try it on your own. I'm going to gather like terms right now. So here's the terms gathered. We distributed our negative. So now we have a negative 3m squared, we have a negative 2, and we have a negative 2m. So we have negative 2m squared minus 3m squared, right? Negative 2m squared minus 3m squared. 5m minus 2m, and then 8 minus 2. Combine your like terms. I used m here to show you, I'm pretty sure a lot of you are getting comfortable with x. It is okay to use other variables. You just gather your like terms with those variables. So these examples are not going to be doable with algebra tiles. They're going to be decimals, but it's the same thing. You're going to gather your like terms and talk yourself through it. So let's gather our like terms, our x squareds and our x's together. There are no 1's here to show. So 3.5x squared plus 5.5x squared, put those together. And then we have 1.2x plus 3x, put those together. When I add them together, 3.5x squared and 5.5x squared, that's going to give us a 9x squared. 1.2x plus 3x, 4.2x. Keep in mind we have a negative here. We're subtracting this expression from this expression here. So everything's going to switch its sign, right? We're going to distribute the negative. You're going to gather your like terms. So now we have 6y squared plus 5y squared. We also have negative 2m squared on its own, because there's no other m squareds here to show. And we have minus 3m squared, right, because we're taking away 3m, not squared, sorry. And we have 3 here, taking away 2. We can combine our like terms, and we get 11y squared minus 2m squared minus 3m plus 1. Just like our x's, you cannot combine the m squared with the m. You can also write your answer like this, because the 11 and the negative 2m. The 11y squared and the 2m squared are both the same degree. Okay. Now we have 3.5 minus 15.2r plus 2.5r squared minus 4.6r squared plus 2.2 minus 19r. We're going to combine our like terms. So I put all my r squareds together, put all my r's together, and I put all my 1's together. And I did that through distributing my negative. All the signs are switched, as you can see. Right? My 4xr squared, 4.6r squared, is now a negative 4.6r squared. My 2.2 is now a negative 2.2, and my negative 19r is now a positive 19r. Add together your like terms, and we get this nice polynomial expression here. Okay, so a classic question I'll be asking is expressing a perimeter using polynomial expressions here. So I have 3 side lengths, and remember, you find a perimeter by adding up each side. So we're going to add together each side length. All right, so we have 3 polynomial expressions being added together. It's the same thing. We're going to add together our like terms. How many x's do I have? Well, I have 2 here, 3 here, and 2.3 here. How many 1's do I have? Well, I have 2 here and negative 1 here. So here's me adding together our like terms. And we get 7.3x plus 1. Now, what's this representing? This is representing our perimeter. So I can ask questions now. Like, if the perimeter was 22.9 meters, then what is the value of x? Well, I know our perimeter is equal to 22.9, and that our perimeter is also equal to 7.3x plus 1. So 7.3x plus 1 is equal to 22.9. We're going to subtract 1 from both sides. So now we get 7.3x is equal to 21.9. Then I'm going to divide each side by 7.3. So let's just show that there. Taking away 1 from both sides. All right, and then we're going to divide by 7.3 on both sides. That means x is now going to equal 3. So when x is equal to 3, this expression, these representations for each side, will add up to 22.9, and only when x is equal to 3 in this case. All right. That's the end of our adding, subtracting polynomials video. Our next video, we'll learn how to multiply polynomials. Thank you for watching.